So the free body diagram of the car, it has an f of g and an f of n because, well, it's a car, it has mass and gravity, and the car is pushing off of the surface. That's why f of n is there, and f of n also has components. Let me label f of n down here. F of n has a vertical component, f and y, and a horizontal component, f and x. And there's also the acceleration going towards the center. Part B, the normal force. Okay, so we know that the normal force from the Pythagorean theorem is equal to f and x squared plus f and y squared. And we know that fg equals to f and y because the car is not moving up or down the ramp. And we know that f n of x is the only force acting towards the center. So it is the centripetal force. So f n equals to, and I'm going to take the square roots of mv squared over r squared plus mg squared since the question asks us to give us the answer in mv, h, and theta, we want to get rid of this r, and the r is this radius right here, and we know that opposite over adjacent tangent of theta equals r over h, and we multiply h over to get h tan theta equals to r, and so we can substitute that back into your equation. Find f of n equals to mv squared over h tan theta plus mg squared. That is under a radical, square root, whatever. And let's see, next question asks us to find the FC. We know that FC equals f and x because it's the only force pointing towards the center. And we know that if we take this as theta, actually this should be, theta should be this angle, and the reason why it's that angle is because if we take this as f of n, then, and this is f n of x, and this is f n of y, and I'm gonna move this over here, then, well, this is not a right triangle. This angle right here is, let's see, Actually, I'm gonna move fn of y back here, and let me see, fn of x up here, just to match our free diagram drawing. So I'm just gonna draw this line here. If this is 90 minus theta, then this entire side here is a right a 90-degree triangle. So this here has to be theta, which means this here has to be theta, because that's how geometry works. So the angle up here is theta, and let's see, fn of x is, let's see, cosine of theta equals to fn of x over the hypotenuse of f n, and sine of theta equals to, that's the opposite of this, f and y over f of n. What are we solving for? C? So we want to find f of an x. So we can multiply fn over to get f of n cosine theta equals to f n x, which equals to f of c, and we know what fn is, so we can plug that in. Fn, let's see, fc equals to mv squared over h tan theta squared plus mg squared times cosine theta, that equals to your fc. Actually, now that I think about it, there's a more simplified solution for this. We can find f of n by multiplying and dividing those over. F of n equals to f n y over sine theta, and we can plug this into the fc function right there to find f n y sine theta times cos theta, and these make a cotangent, and f of y we know is equal to f of g, which is equal to mg. So fn equals to mg cotangent theta, and this is fnx. The next part is derive an expression for v, and I want to use my fn of x function that we just derived for this, because fn of x goes to fc, G cotangent data equals to mv squared over r. And we want to solve for v, so we multiply the r over. The m's cancel out. G cotangent data, and that equals v squared. We can take the square root of both sides to get RG cotangent data. Square root of RG cotangent data equals to the velocity. However, the question asks to find the expression in terms of the given quantities. So we want to get rid of the r, and we found earlier that r equals to h tangent of theta, so we will substitute that in. So h tan theta times g cotangent theta over under a radical equals to your velocity, and tangent theta and cotangent theta cancel out, so the velocity is equal to the square root of h times g. For part E, the Vmax with friction. So as for the maximum velocity and the minimum velocity, if there is maximum velocity, the car is going to try to move upward as it is going fast, which means that our F of S, static friction, is going to try to move in the opposite direction to keep it on moving around on the same plane. And if the car is moving slowly, the opposite can be said. F of g will push it down, which means that F of x will be, static friction will be going up instead. So if we want to find the maximum speed, we want to, let's see, so F of c equals to, let's see, if your car is moving fast, then static friction will want to pull it down. And static friction goes that way and that way. Those are its components, which are pulling it left and downward. So F of c equals F Fsx plus the F and x, which is also pointing towards the center. Let's see, we can substitute Fc for v squared over r equals to F of s is, let's see, mu s equals to F of s over F of n, and F of s equals to let's see, where is data on this. So if F of s is parallel to the curve that the car is moving around on, and f as x that we are looking for is pointing towards the center, and this is a 90-degree triangle, then this data is equal to this data because they are similar triangles. And so let's see, this is the opposite and this is the hypotenuse. Sine theta is equal to fsx over fs. Let's see, then if we multiply fs over and divide both sides by sine theta, we get f of s equals to fs of x over sine theta. Actually, why did I divide sine theta over fs sine theta? And the reason why I want fsx is because I'm going to plug that into here. So this is fs sine theta. And fn of x, did we solve for that earlier? We said that fn of x equals to fn cosine theta. And let's see, we want to find it in terms of r, g, mu, s, and theta. So I'm going to see. So I'm gonna separate fs sine theta into mu s fn sine theta and fn cos theta, and that equals to mv max squared over r. And after this, I want to take out the f of n, leaving us with cos theta plus mu s sine theta and that equals to mv max squared over r. The next step would be to solve for f of n, and let's see, I know that I'm just gonna say that since this isn't moving up or down, the f and y, which is pointing upward, and minus fg, which is pointing down, and fs of y, which is also pointing down, that equals to 0. And let's see, I know that f and y, and I know that fg is mg, and fsy equals to fs, and that is adjacent, so that's fs cosine of theta equals to 0. And I can also split fn of y into f, and see the angles there, so that is sine theta minus mg minus, I can split this into mu of s times fn times cosine theta. And the reason why I can use fn is because that's how you solve for friction. Mu s equals to fs over fn, and so I'm gonna solve for fn by adding mg over and then taking out the fn from the remaining two terms and then dividing that, so it's fn equals, let's see, mg over, so that's sine theta minus equals cosine theta. And I can put that in here to find that, let's see, mg cos theta plus mu s sine theta over sine theta minus mu s cosine theta equals to mv max squared over r. I can multiply over r and cancel out the m's, and then take the square root of both sides to have a final equation of v max equals to rg cosine of theta plus mu. There's only static fixtures, so I'm just going to use mu and rather than mu s sine of theta over sine of theta minus mu cosine of theta over a radical. And let me just minimize and move my work so that it doesn't get in the way of the next question. I'm gonna put this up here. For f, derive the function for the minimum speed. It's quite similar to the last question, except f of s is moving upward, so fsy is going up and fsx is going to the right. So let's see, f of c equals to f and x. It is pointing away from the center, so it's minus f s of x this time. I can split up f of c into mv squared and v minimum squared over r, and f of x I can split into f of n cosine theta like the other problem, part E, and let's see, f s of x I can split into f sine theta, and that is, let's see, I can split up f of s into mu s f of n, and then I can take the f of n out. F of n equals, no, not equals, f of n cosine theta minus mu I'm not going to put in the S. I'm just going to put mu because there's only one type of friction in this scenario. Mu sine theta. And let's see. F of n we saw for earlier in the other equation. It was actually the F of n would be different because static friction is moving the opposite way. So let's see. F n of phi minus fg, and this time we're doing plus fsy because it's moving upwards, and that would equal to 0. Let's see, fn sine theta minus g plus mu f of n cosine of theta equals to 0. And I'm taking these values from the previous part, and let's see, if I solve for f of n equals to mg over sine theta minus mu cosine theta, and I'll plug that into here. Mg cos theta minus mu sine theta over sine theta oh right, this is a plus because there is a plus sign right here. G plus plus mu cosine theta, and that equals to this. Cancel out the m's, multiply over the r, and take the square root of both sides. We get v min equals to the square root of rg cos theta minus mu sine theta over sine theta plus mu cosine theta. And that is our answer for part F. I'm gonna move this over for the last problem. Proof that the net force is given by that. So I know that the net force is of C. That equals to M. When I write it, Gm mv squared over r, and we know what velocity is from our previous equation. So goes to m. Can I copy and paste this? I don't want to write it again. Okay. Rg cos theta minus actually we should use our Vmax function, so it's plus mu sine theta over sine theta minus mu s cosine theta square root over r. forgot the square root, but that in the square cancels out. So we're left with mrg cos theta plus mu sine theta over sine theta minus mu cosine theta over r. And let's see, the r's also cancel out. So we were left with f net equals 2 mg cosine theta plus mu sine theta over sine theta minus mu cosine theta. And if I divide everything by sine, so I multiply this by 1 over sine theta and 1 over sine theta. Every term gets divided by sine, so this distributes here and here, and this distributes here and here, and it gives us, let's see, mg cotangent theta plus mu over sine divided by sine is 1 minus mu cotangent theta, and that's equivalent to this. So that is the proof that is the net force of the function.